Good morning. Now we're going to go ahead and move on and do a lesson on solving multiple step equations. So we've got one step, hopefully two steps down. Now we're going to add some things like adding like terms and moving variable terms around. So we're going to add a few more steps to this. So our first example that we're going to take a look at is having a problem that has variables on both sides of the equation. So before we would have like maybe 4x minus 2 equals 10, but now we've got an x on that right side of the equation as well. So, excuse me, when we have an x when we got the variables on both sides of the equation, we need to move one of those in the same fashion that we would move a constant or a number. So because we have 4x or 4 times x over here, and oftentimes I'll say something like that's 4 x's, and I have 1 x on the right-hand side of the equation. I have more x's on the left than I have on the right, so I'm going to move this x from the right side of my equation to the left side of the equation by subtracting x from each side. So over here on the right side of the equation, x minus x is going to just add up to 0. So we'll have a 10 over there. On the other side, I have 4x's minus 1x. That will leave us with 3x, or 3x minus 2, because that minus 2 is still there. We didn't do anything with that. So now we have an equation that looks pretty similar to what we did in the two-step problems. So now we're going to go ahead and continue that process. So we add our 2 to both sides of the equation. And the plus 2 minus 2 on the left simplifies out. And we have 3x equals our 12 on the other side. That's a multiplication, so we're going to solve that by dividing. This is where knowing those one steps really well helps us to get those down. So our x is equal to 4. Dang it. So our check would be 4 times 4 minus 2 equals 4 plus the 10. So this is 16. 16 minus 2 is 14. 4 plus 10 is also 14. So that checks. So that shows me that that is indeed the solution. Kind of hard to read there, but step 1 was I'm going to call it adding a negative x to both sides, or subtracting x from both sides. All right, so let's move on and take a look at a second example here. So our second example involves using the distributive property. So when we have something that looks like the 2 and then in parentheses x minus 3, that means I'm going to take the 2 times everything in the equation. So typically the parentheses mean that we're going to do what's inside the parentheses first, but in algebra, a lot of times that means we're going to have to use and apply what we call the distributive property. So that means we're going to take the 2 times the x and then the 2 times the 3. So that would give us 2x minus 6 as we take the 2 times both of those numbers. And in this example, we have a distributive property on both sides of our equation. Sometimes you will have that, or sometimes you may only have it on one side. So now we're going to distribute our 4. So 4 times 3x is 12x. And then the 4 times the 8 is 32. Notice that the On the left side, the subtraction sign stayed there. On the right side, the addition sign stayed there. So now we've got something similar to our first example. And this time I have more x's because on the right-hand side of the equation, I have 12x on the right and only 2x on the left. So in this case, I'm going to go ahead and add a negative 2x or subtract 2x. Again, those things are the same thing from both sides of my equation. Now be careful here because on the left side, this is minus 6. So this is where it's good to know and remember that a minus in addition of a negative are the same thing. So we're going to think of that. What's left on the left-hand side of the equation is a negative 6. On the right-hand side, we're going to have 10x plus 32. And we're still going to solve for our x. This time, we got to get everything away from the x. So this time, we're going to add a negative 32. So we got to take that number and bring it over here. I'm running out of space on my board. I'm going to take this up to here. Okay. So I have on my left side, I've got a negative 38. And on the right side, I still have a 10x. So this time I'm multiplying here with the x and the 10. So now I'm going to do the inverse operation, which means I'm going to divide. So now the 10 over the 10, it gives us just 1x. So those are going to cancel with each other, essentially. And on this side, it doesn't come out evenly, but I can divide that out, and I will get a negative 3.8. So that's just dividing by 10. So my answer is a negative 3.8. So this is a little bit harder to check because of the decimal and because of the solution. But if we put that negative 3.8 back into x in both places, equals 4 times 3 times the negative 3.8, and then plus the 8. So if we calculate that out, that is a negative 3.8, right? Yep. We should be able to see that those both come out to be the same thing. So on this side, this would be 2 times negative 6.8. On the other side, it becomes 4 times, let's see, that's going to be a little bit more work here. So the 3, that's times, I've got a little sloppy in there. That's 3 times the negative 3.8. So that's going to be a negative 11.8 plus the 8. That's 11. It's going to be 11.4, I believe. So those should come out to be the same thing. So I'm going to go ahead and move on from there. So we're going to go ahead and move to the next problem. So our next example involves a division within the equation. So that means we're going to have to multiply to solve that. So what I would first do is I would look at this left-hand side of my equation. Okay. I'm going to look at the left-hand side of the equation. I'm not going to mark the board, and I would treat it like, what am I going to do with that side? What do I need to do with that side? Because I can't, adding my variables, oops, I didn't end up using, let's call these both x, okay? Because I didn't mean to have two different variables. So we're going to call those both x's. But because of this fraction in here, I want to deal with that side first. So I'm going to add that 5 to both sides. Oops. I'm going to add 5, and that 5 gets added to the 3. Because it's a like term, it's going to add with the number. It's not going to add with the variable. So we would still have x over 3 equals 2x plus 8. Okay, so I went ahead and did that first. So now, again, it's going to be kind of weird to add the x's together here. So what I would go ahead and do then is let's go ahead and multiply both sides by that 3. So we're going to go ahead and do that step now. And the thing on the right-hand side is that we have to multiply everything by the 3. We can't just multiply one thing. So when we do multiplication or division, we have to make sure that we do it to every piece of that equation. So on the left-hand side, our 3's are going to, multiplying by 3, dividing by 3 are going to cancel with each other, just leaving us with a single x. And on the right-hand side, we're going to have to distribute that 3, giving us 6x plus 24. So now I'll bring that up again to the top. These questions are getting a little longer. I have x plus 6x. X. I don't want to erase the whole screen. I want to do an eraser. I don't have an eraser right now, so that's x equals 6x plus 24. For some reason, all I can do is clear the screen. I can't erase it. So now we have x's on both sides. Typically, I wanted the x to end up being positive, but I want to get them together, so I'm going to go ahead and add the negative 6x to both sides because I want to move it away from the 24. I want to get the x on one side and 24 on the other side. So that gives us a negative 5x equals 24. This one, again, isn't going to come out to be a nice whole number, but that'll be okay. We go ahead and divide by the negative 5. So this is our final step, our one, kind of like the one steps like we started with. Dividing positive divided by negative will give us a negative. So x will give us a negative, and if I do that on a calculator, I will get a negative 4.8. And again, we're kind of out of room to do the check, but we could substitute that back in on both on the left side and the right side to verify that solution. And all right, I think I have one more example to do. And this example is another one with the division, but this time we have the whole thing, the whole side of the equation, the whole left over here is over 4. So this is an obvious, I'm going to treat this like I did before. I'm going to multiply both sides of my equation by the 4. That 4 is going to cancel with this 4, leaving us with 3x minus 7. And on the right-hand side, we're going to distribute 4x plus 20. That's a 20, not 26. And now we can put our terms together. Put our x's together on the same side of the equation and put our numbers together on the opposite side. I like to move the smaller number of x's to the larger number of x's when possible, if that makes the most sense. So I'm going to add a negative 3x to both sides, or subtract the 3x, leaving me with, remember, the negative is still there, a negative 7 equals 4x minus 3x, just leaves us with 1x plus 20. So again, we're going to bring it up over here. So I've got a negative 7 equals x plus 20. So now we just subtract 20 or add a negative 20 to both sides of our equation, leaving us with a negative 27 equals our x. So again, we could substitute that back in. It's getting a little bit more involved because our equations are a little bit more involved. But if we took 3 times the negative 27 minus our 7 and divided that answer by 4, and then on the other side, we would take a negative 27 plus 5. So that leaves us with a negative 22. That side's not too bad to do. The other side, hopefully that would also give us that as we go through that. All right, so that's our last example of multiple steps. Hopefully you had a chance to write some of those down and follow along. I think if you write those down, it kind of helps you to have some examples for you as you do the practice problems. So now if you could try the worksheet or the practice problems and ask questions if you have questions via email. Thank you. Have a